Look at the volume and speed of data moving across this network. This is the RP1 spatial fabric, routing millions of geometric data packets. But notice how this specific payload is now wrapped in a protective envelope. That envelope is a universal manifest. It is the per-entity permissions layer that sits on top of the RP1 spatial fabric. The division of labor here is precise. RP1 handles the geometry, routing messages and managing the scene object model, or SOM. Universal Manifest handles the context. It carries the identity, the user consents, and the verifiable credentials across those routed messages. The Universal Manifest specification does not replace RP1's native spatial addressing, it composes with it. A spatial computing browser must secure user context without slowing down the rendering pipeline. By separating permissions from geometry, this integration provides the deterministic handshake required to operate at scale. Here is that process at the protocol level. A user's Open Metaverse Browser Initiative, or OMBI, node approaches a destination world node. In the milliseconds before entry, both the user's browser and the destination world pause. They evaluate each other's manifests simultaneously. This diagram shows how those data structures expand to reveal facets for identity and capabilities, with logic lines reaching across the gap. The system evaluates these connections to see if the minimum requirements for entry are met. Once confirmed, the exchange produces a record. That crystalline receipt is a cryptographically verifiable record of exactly what was accepted, refused, or unsupported during the exchange. Access in the spatial internet is not unilateral. An entity only enters a new domain when the universal manifest proves mutual acceptability. We can apply this handshake to a consumer scenario. Watch as this avatar physically crosses a boundary line into a new RP1 virtual world. This triggers the first integration group, spatial addressing. Universal Manifest references RP1's spatial addresses, utilizing precise geopose coordinates to evaluate location-based facets the moment an entity enters an addressable region. This leads to the second group, RMAP service credentials. Because the Universal Manifest envelope carries these RMAP-issued credentials, the destination world can verify entitlements like ticketing or age requirements automatically. The avatar does not need to pause and represent credentials. The destination world immediately processes accessibility preferences and content rating facets. The avatar arrives configured for the environment before the user even takes control of the camera. By moving credential evaluation to the threshold, configuration precedes rendering. This architecture is vital for enterprise environments, such as this digital twin of a factory where a technician approaches an industrial press. This relies on the third integration group, SOM branch authorization. Universal Manifest carries the specific authorization allowing an entity to branch into a subworld or interact with an isolated object model. That authorization is tied to the fourth group, the content trust chain. The envelope carries provenance signatures, so the factory world can verify imported WebAssembly modules are trustworthy before they are instantiated. Back in the factory, the heavy press projects its own Universal Manifest, containing a time-stamped service history. The evaluation is bilateral. The technician's headset evaluates the machine's manifest, and the machine evaluates the technician's RMAP credentials to confirm they hold the required certification. In these industrial environments, physical safety depends on cryptographic verification preceding the execution of code. If we pull back to a God's eye view, the entire facility operates as a primary RP1 spatial fabric. Now, watch as a secondary overlay, representing real-time IoT sensor data streams, descends and securely locks on to that primary factory fabric. This introduces the fifth integration group, primary-secondary fabric composition. A bridging Universal Manifest envelope sits precisely at the boundary between these two fabrics. The facets within this envelope describe the relationship and data-sharing rules between the primary session and the secondary overlay. This governance ensures that even when an entity interacts with multiple third-party services, data cannot leak across fabric boundaries. This enables multilateral spatial composition while maintaining the security boundaries and audit trails required for enterprise deployments. Zooming out further, we see thousands of simultaneous connections across an interconnected RP1 landscape. Every glowing connection point represents a Universal Manifest envelope, confirming that every interaction leaves a verified trace. Universal Manifest is the portable permissions envelope that completes RP1's addressing and trust mechanisms, and it does this as an official standard, governing these exchanges with proven interoperability. The Universal Manifest specification is continuously evolving, with future work at OMA 3 supporting increasingly complex spatial computing capabilities. This overview represents only the ecosystem introduction to the architecture. For systems architects and developers, the next step is to watch the technical deep dives covering spatial addressing, RMAP credentials, SOAM authorization, content trust, and fabric composition to begin implementation.